So we know that generally EMF is directly proportional to number of turns. So if turns in primary is N1 and turn in secondary is N2, so we know that ratio of EMF induced will be equal to N1 by N2, right? And also we know that EMF is current, so I1 and similarly E1 by E2 will be N1 by N2, and we also know that power is same, so E1 I1 is equal to E2 I2. So from here we can write is E1 by E2 will be I2 by R. So this formula will be mostly used in all the questions. E1 by E2 is equal to N1 by N2, and that is equal to I1 I2 by R. You know this formula? We don't need to go much detail in the theory. The most basic formula is this one, and that will be used. You know this formula? I think you should know this one. And also we will use some efficiency formula, like efficiency of a transformer is given by power output by power input, right? Output power is power across the secondary, that is I2. You can write it like I2 into, so EMF E2 and power input. So generally output power will be given, and sometimes you have to find power loss. So the most important formula is you have to know efficiency, that is power output by input, and accordingly we can do the calculation. So for ideal transformers actually efficiency will be 1, but for non-ideal transformer E2 by I1 power input will not be equal to power output. So we will see the questions, then we can understand more and more concepts. So let us directly jump to the questions based on transform. So first we will do some basic questions, then we will do. And also we have some idea, like a step up transformer means number of turns in the secondary will be more than primary, that is called a step up transformer. And in a step down transformers, number of turn in the secondary is less than number of turns in the primary. You know these things, we have common idea, right? So let us do some questions. Attempt this question number 35. This is NEET 2014. So attempt this question first. I will give you some basic hint to solve these questions. So let us see. So this question says a transformer having efficiency of 90% is working on 200 volt and 3 kilowatt power supply. If the current in the secondary coil is this 6 ampere, then voltage across the secondary coil and the current in the primary coil respectively are. So efficiency is given. So from here what you I will give you a hint. What you can do, efficiency means power output by power input. So power output is V2 I2 by power input is V1 I1. So I2 is given I2 is given as 6 ampere. So now can you do that? So you have to find V2, and then you have to find I1. Got it? So try to solve it, then I will do it. Attempt this question.
Okay. Sir, is it option B?
Have you got it?
Yeah, option number B.
You got option B. Let us check. Yes, B is correct answer. So should I solve it now? You understood?
Yes, sir. I understand.
Okay. Let's do the next question. Try question number 36. You are preparing for NEET, right, Ramana?
Yes.
Nifa, are you getting it after a long time?
Yes, sir. I'm trying.
Try this question. The question says the primary of a transformer when connected to a DC battery of 10 volt draws a current of 1 milliampere. The number of turns of the primary and the secondary windings are 50 and 100 respectively. The voltage in the secondary and the current drawn by the circuit in the secondary are respectively. So N1 and N2 are given. In the question it is given that N1 is 50 and N2 is 100. So we have to calculate the voltage in the secondary and the current run by the current in the secondary. So we have to calculate E2 and I2. And also it is given that E1 is 10 volt and I1 is 1 milliampere. Nothing we can calculate. Try to solve it. We have to apply the formula E1 by E2 is equal to N1 by N2, and that is equal to I2 by I1. So apply the formula and tell me the answer. Any answer? Here we had to apply this formula. E1 by E2 is equal to N1 by N2, and E1 is given as 10. E2 we have to calculate 50. So from here we will get EMF E2 is equal to 20 volt, right? Also we can do it like N1 by N2 is equal to, that will be equal to I2 by I1. So I2 we have to calculate. I1 is 1 milliampere and N1 by N2 is 50 by 100, right? So from here we can calculate I2, which is 0.5 ampere. So I2 will be 0.5 milliampere. What is correct answer? 20 volt and 0.5 milliampere. So the correct answer will be A. Got it? Both of you understood this?
Yes.
All right. So questions are generally not tough in NEET. This is NEET 2013 questions. If we know the basic concept, we can solve transformer question easily. Not much difficult questions are asked generally in this. Now do question number 37. I will give the hint for this question. It says a 20 volt input is applied to a transformer. So input voltage is given, right? V1 is given as V1 or E1, we can say that is given as 220 volt. The output circuit draws a current of, so I2 is given as 2 ampere and V2 is also given, which is 440. If the efficiency of the transformer eta is given 80%, the current drawn by the primary winding of the transformer. So we know that eta is output power by input power, and what is output? V2 I2 by what is input? V1 I1. So we have to calculate I1. All the things are given. Put the formula and tell me the answer. Got any answer?
Option A.
You got option A. Let me check. D is the correct answer. How you got A? Let us check. So put the value of eta. Eta is 80 by 100, 80%. And V2 is 440 into I2 is 2. V1 is 220 into I1 we have to calculate. So from here, this will cancel out. It is 2 and this is cancel out. So I1 we will get it as 8 by 10. Sorry. I1 will be equal to 2 into 10. 2 into 10 into 2 divided by 8. That will be 5 ampere. Got it? Understood?
Yes.
So, okay. Attempt question number 38 and 39. So I will give you a hint here. The primary of a transformer have 50 and ether turns respectively. So N1 and N2 is given. And if you see, this is N1. N1 is given. And N2 is also given. If the magnitude of magnetic flux linked with the primary coil is given by this, where phi is Weber, T is time in second, and constant, the output voltage across the secondary coil is. So we know that flux of primary is given. You can say it is phi 1 is given. Phi is equal to phi naught plus 40. So we can calculate even EMF associated with primary. How will will be that? D phi by dt. So from here, what you will get? You will get 4. Getting my point? So now everything is sorted. We have to calculate E2 only. Even given. Got my point? Calculate it. And given even we can calculate from d phi by dt. We know that EMF induced is rate of change of flux. Any answer? We can write like this: E1 by E2 will be equal to N1 by N2, and N1 is 50 and N2 is 1500. So 1 by 30.
Option A.
You got option A. And so, and E1 is 4, E2 we have to calculate. So from here to S 120. Yes, you were right. Answer is A. So see, questions are not much difficult. You have, if you know the basics, you can easily solve the questions. So if you see here, what was the concept? The main concept was like the EMF is given by rate of change of flux. So this is the main turning point of this question. If you can click this one, if this one clicks in your mind, you can easily solve the question. Otherwise, you can't solve this question. It is very important that you should know how to apply the right concept at the right time. That is the thing. If you can understand, then you can do the question. What happens generally? What happens? We know the concept, but we don't, apply that concept at right time. So we have to understand that, and that comes from practice. If you do more and more practice, you will be automatically you will identify which concept has to be applied and where it has to be applied. That is very important. Now do question number 39 of 39. Any answer?
C.
So you got C, not C. Recheck your. Let us check. Hmm. A transformer used to light a 100-watt and 110-volt lamp from a 220-volt mains. If the main circuit is 0.5, the efficiency of the transformer is approximately. So, what is this? Is output power, right? And this is V2, and this is V1. This is I1. So we have to find efficiency. So how to calculate efficiency? Efficiency is output power by input power. So that is 100 by it is input power V1 I1. So what is 100 by what is V1? 220. What is I1? 0.5. So we will get it as 1000 by 5 into 220. So that will be 100 by 5 into 2, 50 by 22, 25 by 11. So it will be like let us check the calculation. 1000 by this. So sorry, there is a mistake in calculation here. Efficiency cannot be greater than 1, right? So it should be 100 by 5 into 22. So 20 by 22 and 10 upon 11. So that will be we divide 10 by 11. So 9. Point 9 something. So what was the answer? 39. B. We are getting approximately 0.9 something, right? That will be approximately 90%. Got it?
Yes.
It was very easy. Only you have to do P out by P input. So the main thing is we have to understand what is output power. The transformer can light a 100-watt bulb, means its secondary is connected. Generally secondary is connected to the output, right? We know that secondary is generally connected to output. So here basically the secondary is connected with the bulb, and the efficiency of secondary will be same as efficiency of output of the bulb. So output power of the bulb is given as 100 watt, and this will be same as output power of secondary, right? So this we have to understand. If we can understand this, we can do the question. Got it? All right. Theoretical question you can do like 40. You can see 40 question. What it says according to 40. The core of a transformer is laminated because energy loss due to eddy current. Generally, lamination is done due to minimize eddy currents. So 40, we are laminating the core to minimize the eddy current loss, right? So theoretical. Similarly, if you can see 44 question, eddy currents are produced when a metal is kept in varying magnetic field, metal is kept in steady magnetic field. Obviously, when a metal is kept in varying magnetic field, eddy current is produced. So for 44 also answer will be A, for 40 answer will be D. So these are easy questions. Now you can apply question number 41. So attempt question number 41. This is based on LC oscillation, and we know the frequency of LC oscillation is 1 by angular frequency is 1 by LC. So I will give you a hint for this. This is a transistor oscillator using a resonant circuit with an inductor L of negligible resistance and a capacitor in series producing oscillation of frequency F. If L is double and C is changed to 4C, then so I'm giving a hint. What is the formula? We know that omega is 1 by LC and frequency F will be omega upon 2 pi, so 1 by 2 pi into 1 by root LC. So this is the frequency. Now try the question. So basically what we have to do, we have to write F1 by F2. F1 is given as F. F2 we have to calculate, and that will be equal to under root L2 C2 by L1 C1. Now you can easily find out, put the values and tell me the answer. Any answer? Put the values. So you can put the values like this. What is L2? L is double. So L 2L and C2 is also 4C. Initial inductance is L and C. So that will be equal to 8, right? So F2 will be equal to F by root 8. And what is root 8? F by 2 root 2. Correct answer is B. Got it? Moving to the next question. Not on question number 42 and 43. Any answer? See, says that this type of transformer operates on a 230-volt line. So what is this? 230 volt is V1, input voltage, right? V1, and supplies a load 2 ampere. It means what is this? I2. So this one is basically I2. The ratio of the primary and secondary windings is this. So N1 by N2 is given as 1 by 25. Then current in the primary is, we have to calculate I1. So again, we have to apply same formula. V1 by V2 is equal to N1 by N2. So what is V1? V1 is given 230. V1 is given as 230 by V2. And V2 is not known. So we can also do that. We don't need, we can write I1 I2 formula. So that will be equal to I3 by I. So N1 by N2 is given, that is 1 by 25, and I2 is given as 2 ampere, and I1 we have to calculate. So from here I1 we will get as 50 ampere. Understood? So you have to be very careful which formula should be applied. If you will use here V1 by V2, then you don't know V2. So it's better to use N1 by N2 is equal to I2 by I1. That will be easier. So you have to see which formula should be applied. Understood? Got it?
Yes, sir.
Alright. Moving to the next question and last question of this chapter. Then we will start new chapter. So now we have to see question number 43 and 44. Try this question. Try this question.
Option D.
You got option D. Let us check. Yes, D is the correct answer. Should I solve it?
No, sir.
All right. So we have completed this question, all the question of AC, and till now any doubt? I think we have done
No,
enough
sir.
questions for practice. We are clear with the transformers, LC circuit, RC circuit and all. So moving to the next chapter, that is chapter 7, electromagnetic waves. So that chapter is basically not uh, much theory in that chapter. We have limited theory. So mostly we will do questions, and we have basic concepts of equation of wave and all, we can easily do the questions. So let us start chapter 8. EM waves, electromagnetic waves. So as the name suggests, here we will have both the things like electricity and magnetism, both are involved. Till now we have studied electricity separately and magnetism separately, but here we will have concept of both electricity as well as magnetism. And EM wave, what is that? We know that light is EM wave. So EM waves are basically electromagnetic waves are basically transverse waves, and like light and different radiations like gamma radiations, X-rays, ultraviolet radiations, which we have heard, like ultraviolet, UV rays, infrared, X-rays, gamma rays, and all these are electromagnetic waves. So there are some common properties and some frequency range also. So the basic layout of this chapter will be, first we will study source of EM wave, how an electromagnetic wave is generated, source. Then we will study some like characteristics of EM wave. Then we will see characteristic. In this we will study equations and all. What is the equations of EM waves and all. We'll study in this. Then we will go to properties of EM waves. Properties. And then we will move to uses and applications. So mainly these will be basic layout of the chapter. First we will study source of electromagnetic wave, then we will study characteristics, then what are equations of electromagnetic waves, what are their properties and uses. So this is the basic layout. I will not go much detail in the theory. I will take some important points and directly we will do questions from NEET point of view. This is very important chapter. Questions generally one or two questions are asked in the exam. At least one question is necessary. So first, if we talk about source of EM wave, Very simple. Accelerating charge, and accelerating charge produces EMF. Accelerating charge produces EMF. So any charge which is accelerating means it can oscillatory also, like you have seen in LC oscillations. In LC oscillation, what we have seen, charge is basically accelerating. So that can also produce EM waves. And we also know that an accelerating charge is having both associated magnetic field as well as electric field. So we know that for electromagnetic field, both are required. So when a charge is accelerating, it will have associated electric field as well as magnetic field. When a charge is accelerating, it will have current, and we know that current is produces magnetic. So both will be associated with a charge. One, we all know a charge is having electric field associated with that, and apart from that, because of its motion, we can say a moving charge acts like a current, so it will also produce magnetic. So whenever there is both, we call it as electromagnetic wave. If we talk about characteristics and so generally how we represent an electromagnetic wave, that we have all have seen the, like, generally we represent an electromagnetic wave as a sinusoidal wave. It is not always sinusoidal, but for our simplicity of a study, we take sinusoidal. If it is another kind of wave or another kind of pattern, it is difficult for us to analyze that. It is always easy to understand sinusoidal wave. That is why we are taking sinusoidal wave. Generally, we represent electromagnetic waves like this. A sinusoidal wave is represented by this. So here we have to show both electric as well as magnetic field, right? So we can also show magnetic field like this. There is always associated magnetic field also. So it will having associated electric field as well as associated magnetic field. You may have such kind of graph in the book also, kind of thing. So basically I am showing it by two color. It means showing these two components are perpendicular to each other, right? So we can represent one by magnetic field. Suppose I have represented this as magnetic field, and one will be electric field, like that. So both are perpendicular to each other, and the wave is propagating, suppose, in this direction. So basically what happens is that is very important. And first you can see, like, suppose you are representing electric field in this direction, and suppose magnetic field is in this direction. Suppose electric field is in x direction, magnetic field in y direction. So wave will move along z direction. So basically the direction of wave, this is very important. Direction of wave is given by E cross B. Direction of wave is given by E cross B. Here you can see what is the direction of electric field. X means I and B is along y-axis. So I cross j gives k. So it means here wave is propagating along z-axis, but electric field and magnetic field are perpendicular to each other. So basically, the propagation of wave, electromagnetic wave, electric field and magnetic field, all are mutually perpendicular to the each other. Similar as x, y, z and x, y and z axis are mutually perpendicular to each other. In this similar way, in electromagnetic wave, electric field, magnetic field, and direction of propagation of wave, all three are perpendicular to each other. That is the basic thing that we have to understand. Now equation we can easily write. We know that in a wave, like if a wave is sinusoidal wave, we can represent electric field. Suppose electric field is in x direction, so we can represent electric field like E is equal to E naught sine omega t minus phi or something like that. So, and if electric field is along x direction, it can be represented like E naught sine omega t minus phi. Similarly, you can represent the magnetic field. If magnetic field is along y direction, we will put it as J. So here we know that, like here E naught will represent uh, amplitude of the electric field. We know that, and the direction of wave is along, direction of electric field is along x direction, and direction of wave is along z direction. Getting my point? So similarly, we can represent electric field also, or like magnetic field also. And one thing is missing here. Okay, we have to also put for if the electric field is along x direction, or here wave is propagating along z direction, right? So we can write equation like kz. Here wave is moving along z direction, so kz minus omega t kind of thing. So basically, this will represent the electric field, and this will represent direction of wave motion. Similarly, if you want to write like magnetic field equation, you will write like this: B is equal to B naught sine kz minus, so kz minus omega t will be common for both. So this term basically inside terms represent the direction of wave motion. This term will represent direction of wave motion, and the outer thing will represent electric field and magnetic field. If electric field is along x direction, we will give it as I. If magnetic field is along y direction, we will put it as J. And also we have to see inside sign here. If direction is propagating along, if the wave is moving along plus Z, we will give minus sign. If it is, we are always giving opposite sign. If it is moving along plus Z, we will give minus sign. If it is moving along minus Z, we will give plus sign. Got my point? Understood? So this is how we generally represent equation of electromagnetic wave. So understood till now? Any doubt? Any doubt, Mamuna, Hanifa?
No, sir.
So let us do some basic questions based on EM wave. Question are generally very easy from this chapter. So let us see. Now attempt question number second. Attempt question number second. I will give you a hint for this. So the question say an EM wave is propagating in a medium with a velocity this. So here what is the direction of wave? Basically I is the direction of wave. Direction of wave motion. Right? Direction of wave motion. The instantaneous oscillating electric field of this EM wave is along y-axis. So electric field is along y-axis, correct? Then the direction of oscillating magnetic field. So we have to find the direction of magnetic field. So you can draw a diagram like this also. Here what happens? What we know that E cross B, we know that E cross B, as I have dictated you, like the direction of E cross V. We know that direction of E cross V gives the direction of wave. This is very important. E cross B gives the direction of wave. So here also E cross B will give the direction of wave, means E cross V should produce what the direction of wave? I. And it is given that electric field is along J direction, right? In the question it is given that electric field is along Y axis. So it means J cross, and we have to find the direction of magnetic field. So it means J cross B should give I. So we know that what is, if J is equal to K, if it is K, so we know that J cross K is equal to I. And what is the K means? Positive Z direction. So where will be that magnetic field? Along plus Z direction. Understood? Got my point? So you have to remember this one, this circle. Always remember this. I, J, I, J, K. If you remember this, you can. This will be very important here. In clockwise or anti-clockwise, I cross J gives K, J cross K gives I, K cross I gives J. So this will be very important and much in use in this chapter. So here I will dictate you, here I will explain you again how this comes. We know that E cross B is equal to the direction of wave motion. In the question it is given that wave is going along X direction. So it will be I, and the electric field is given along Y direction. So it should be J. So what we have to see, where should, should be the direction of K, what should be the direction of magnetic field, such that its cross product will produce I. So now we can have an idea that if it is K, and we know that J cross K is I. So now from here we found an idea that magnetic field should be along plus Z direction. We have predicted that. Understood this one? So the direction of magnetic field will be plus Z direction. This is very important to understand, and this is NEET 2018 question. So both of you understood? Maimuna, Hanifa, any doubt, please ask.
No, sir, no.
Got it?
Yes.
All right. Now attempt question number 8. Attempt question number 8. So here the wave equation is electric field equation is given. So now we have to calculate the wave vector k. What is wave vector k? I will give you a hint here. Basically k is 2 pi by lambda. So if we can calculate lambda, we can calculate k. So how to calculate lambda from the given equation? So basically what you have to do is you have to compare the given equation with the standard equation. What we were doing the 11th class wave. So you have to compare this with this is standard equation. What is that? E is equal to E naught cos. Also you can write cos and sine, the similar thing. So cos kz minus omega t. So if you compare this with this one, you will get omega. Omega is basically 10 to the power 8 into 6. This is omega, and we know that what is omega? Omega is 2 pi by lambda. So 2 pi by lambda is 10 to the power 8 into 6. So from here we can calculate lambda. Lambda will be 2 pi by 10 to the power 8 into 6. So now put the value here. 2 pi by what is lambda? Lambda is